Hi, in this video, we're going to talk about TCP and reliable delivery. So first of all, why do we need reliability? Well, because at times we can lose packets, lose segments due to network congestion. Congestion is when a network node experiences reduced quality of service due to some issues, like having more data than it can handle. Can be due to queuing delay, too many packets in the input queue or output queue, too many coming in, too many going out. And that can be due to lack of bandwidth on the link or interface, more traffic than the device or link can handle, or lack of resources, lack of memory, lack of CPU power. Okay. Congestion can also cause packet loss, one or more packets being dropped, therefore fail to reach their destination. Or denying new connections because more devices than the receiver can handle are simultaneously trying to send packets to the destination. Okay, so TCP congestion control. TCP uses a congestion control strategy involving various mechanisms and algorithms, including congestion control, slow start, and various congestion algorithms such as TCP Tahoe and TCP Qubit, all beyond the scope of this video. But if you remember, in an earlier video, I recommended a couple of books on TCP IP, and there's several good ones out there. But one of the reasons that make the TCP a very sophisticated, complicated protocol to understand are the various algorithms and processes and techniques that have to do with congestion control and congestion avoidance. And a lot of work is still being done to develop new algorithms and new processes to do this. But that's all beyond the scope of this video. What we're going to be focusing on is just reliability. So to do this, the TCP uses a combination of sequence number and acknowledgement numbers to confirm receipt of data that was sent. The sequence number indicates the first byte in a TCP segment. TCP uses an acknowledgement number that is returned, indicating that it has received this information, and this is the next byte expected. So for example, in this top segment here, we see that there's a sequence number of 1. 10 bytes were sent. So because 10 bytes were sent and the initial sequence number, in this case 1, which is not realistic because remember it uses a starting initial sequence number of a large random number. But for just demonstration purposes here, we have a sequence number of 1, 10 bytes were sent. So what this sender expects is an acknowledgement of 11. So a TCP segment with an acknowledgement number of 11 and the ACK flag set at 1. Okay, meaning that it received those 10 bytes and it expects byte 11 next. Okay, so how does the device determine how many bytes were in the TCP, how many data bytes were in the TCP header? Well, that's beyond the scope of this video, but I've added a little calculation to show you if you're curious at the end of this slide. But acknowledgements are known as expectational acknowledgements. Okay, whoops, before I show you that, it's the next byte that if the receive, so here we sent 10 bytes with the sequence number of 1. If this segment was received, then it expects to receive an acknowledgement back of 11, an expectational acknowledgement. I expect byte 11 next. Here's that little calculation if you're interested that determines the length of data in a TCP segment. Just a little extra for you. All right, so here's an example. Again, I'm going to start with byte number 1, sequence number 1. I'm sending 10 bytes. I've received those 10 bytes, okay, and I expect byte number 11 next. Okay, so this would then, the sequence number here would start with sequence number 11. Okay, here we go, simplified even more so. Okay, so here if we were just looking at sending a window size of 1 byte at a time. Of course, this isn't something we'd normally do, but it would send 1 byte received, the acknowledgement would be 2. Next byte sent, 2, received, acknowledgement would be 3, send 3, acknowledgement 4, next one expected. All right, I want to show you this kind of neat little animation you can use. This is from rad.com. And here I have my window size set at 1. And I'm just going to start this. The sender's going to send a 1 byte at a time and get an acknowledgement for that byte. Later, I'm going to show you how TCP does this using something called sliding windows. Okay, but for right now, just take a look. So we send 1 byte, and the acknowledgement comes back saying I got that byte. It would actually say next one I expect is 2. So it's not showing the numbers here, but we can just see that this is a window size of 1 byte at a time. Okay, we'll use this animation later to show actually sliding windows. Okay. Okay, I hope that helps you understand a little bit about window sizes and a little bit about reliability. A lot more coming up. We're going to look at sliding windows and some other things like SAC, okay, selective acknowledgments. So more coming up.